In this session, we will be discussing about simplified data encryption standard. Simplified data encryption standard is a simple version of the data encryption standard, which has 10-bit key and 8-bit plain text. It is much smaller than the DES algorithm as it takes only 8-bit plain text, whereas DES algorithm takes a 64-bit plain text. And it is a block cipher algorithm, and it uses a symmetric key for the algorithm. That is, it uses both same key for both encryption and decryption. And it has 2 rounds for encryption, and in 2 rounds it uses 2 different keys. So first we need to generate 2 keys before encryption, and after generating those keys we pass them to the individual rounds for SDES encryption. And this is the block diagram of the entire SDES algorithm. This process is the key generation process, which we'll be discussing now. And this side is the encryption, and this side is the decryption. In the encryption side, first the 8-bit plain text is taken, and that is given for the initial permutation. And it is then passed to a function, complex function fk, which uses one of the keys that is generated by the key generation algorithm. And later we perform the switch operation, and the output from the switch is again given to another function, another complex function. In this case, it uses a different key that is generated by the key generation algorithm. And finally, we perform inverse initial permutation to get the 8-bit ciphertext. This is the encryption side. And this is the decryption side, where we take the 8-bit ciphertext and pass it to the initial permutation, and then give it to the complex function, which uses the key K2 that is generated by the key generation algorithm. And that is later given to the switch and next passed to the complex function, where we use another key, which is K1, and later passed to the inverse of the initial permutation to finally generate the 8-bit plain text. So we'll first discuss about the key generation process in detail now. So this is the key generation process. In the key generation algorithm, we accept the 10-bit key and convert it into 2 8-bit keys, K1 and K2. And this K1 and K2 are both shared by the sender and receiver, since it is a symmetric approach. In key generation, we use 3 functions, which is P10, then P8, and left shift. This is the P10, that is, we take the 10-bit input and randomly shuffle those bits to finally generate new bits of shuffled order, and this is P10. Once we perform P10, out of the 10 bits, we take left 5 bits, the first 5 bits, and the next 5 bits. And the first 5 bits are passed to LS1, and the next 5 bits are also passed to LS1, which is the left shift 1. Left shift 1 indicates that we shift the bits by 1 bit. So the B comes here, C comes here, D comes here, and E comes here, and A finally comes here. This is an example of left shift. Supposing if the bits are like this, after performing the left shift by once, this will be the final arrangement of the bits. So once we perform initial permutation, after performing the left shift once and left shift once on the first 5 bits and the next 5 bits, those two are together combined and given as input to the P8. So this is the P8, where we give the input as the 10 bits and finally generate 8 bits. That is, we take the random bits out of those 10 bits to produce a 8-bit. And that 8-bit is the key one that we use in the first function of our DES algorithm. Similarly, we perform left shift one more time on both the first 5 bits and the next 5 bits. We perform left shift again. This is the example of left shift 2. That is, if this is the original bits, when we perform left shift twice, this is the final arrangement of bits. So after performing the left shift twice, we again give that combined input to P8. So the 10 bits are again given to P8 that produces 8-bit key, which is K2. So here we get K1 and here we get K2. This is the process of key generation in DES algorithm. Next, the DES algorithm involves 4 functions, which is the initial permutation, complex function, and complex function is further divided into expanded permutation, S boxes, and permutation P4. And after complex function, the next step is switch, and the last step is inverse of initial permutation. In the initial permutation, we take 8 bits and shuffle them randomly to get again 8 bits where the bit positions are changed. In this case, the first bit is replaced with the second bit. The second is replaced with the 6th bit of the original one. Third is replaced with third, and fourth is replaced with the first one, and so on. And this is the complex function. And this complex function again has 3 subparts, which is the expanded permutation, S boxes, and permutation P4. So the first step is, after getting the 8-bit text, we perform the initial permutation that we have discussed previously, and that is given as the input to the complex function. In the complex function, we take the first 4 bits and the next 4 bits. The next 4 bits are given as the input to the expansion permutation. So the expansion permutation is like we take the 4-bit input and expand it to finally get 8-bit output. This process is expansion permutation. And after we get the 8-bit output from the expansion permutation, we perform an XOR operation with the key that is generated. This is the key one that we are using, that we have already discussed in the key generation process. And by using that key that we have generated and the output of the expansion permutation, we perform XOR operation on both of those to finally get again 8 bits. So these 8 bits are again given as 4 and 4 bits. And the first 4 bits are given for S0 and the last 4 bits are given for S1. So we'll discuss about S boxes now. S box indicates that it is substitution. Supposing if we consider the bits are like 0, 1, 0, 0. We take the first and fourth bit as the row number and second and third bit as the column number for our S boxes. So supposing if the input is like 0, 1, 0, 0, the first bit is 0 and the last bit is 0. And the middle bits are 1 and 0. So 0, 0 becomes the column, 0, 0 becomes the row, and 1, 0 becomes the column. So the row 0, 0, which is 0, and column, which is 1, 0, that is 2. So the value present at that particular location is considered after the S box. Similarly for S1, the first and the fourth bit indicate the row, and second and third bit indicate the column. So based on that particular row and column, the value present at that particular table is considered. And finally, the output is given for, finally, the values from both S0 and S1 are combined and given for P4. P4 is again the permutation of the 4 bits. They are randomly shuffled and permuted to get the other 4 bits. So this is permutation P4. After performing permutation P4, the 4 bits that are generated are performed XOR operation with the first 4 bits of the output of the initial permutation. So the output of the initial permutation, first 4 bits are taken and they are performed XOR operation with the output of P4. So after performing XOR operation, we get a 4-bit output. And the 4-bit output that is already present, that is the last 4-bit output that is already present from the initial permutation, are also considered here. And both of them are performed switch operation. Switch operation, that is these 4 bits are given here and these 4 bits are given here. That is the last step in the switch operation. And finally, we perform the inverse of initial permutation. This process goes on for 2 functions and we finally get the ciphertext out of the plain text. The process and decryption is also similar, but just the functions that are called is just different, but the entire process is almost similar. Thank you.